Okay, this video we're gonna look at lab number 5, which will be on counters. And counters are used in all all makes and models of PLCs. It's a very standard instruction available again in any brand PLC. But a counter, by its nature, is there to count either up or count down, and they are triggered by typically a discrete input that when it transitions to a high, it will count up by 1. So basically, the trigger will have to turn on and then turn back off again. And then when it turns on a second time, it would count up again. So starting with 0, first time it gets triggered, it would go to 1. Second time it gets triggered, it would go to 2, and it would keep counting up potentially indefinitely. Another feature of a counter is you usually would give it a maximum value so that when it reached that maximum value, it would turn on the output, let you know that you have counted up to your maximum allowed count. So for instance, in our lab, we're going to have the premise that we're counting boxes that are on a conveyor belt. So as every box passes a photoelectric sensor, when that box passes in front of that sensor, it'll trigger the sensor. The sensor will go from a low to a high. That'll be the trigger. And it'll therefore count that box as 1. And when we get to 10, when we count to 10, or 10 boxes have passed by the photo eye sensor, then the counter will basically tell us that we've reached the maximum that we want, right? We've reached 10. That'll turn on the output, or the Q, of this count up block. Once you've reached the maximum value, the counter will continue to count up. So if more boxes cross in front of the sensor, it'll continue to count to 11, 12, 13, etc. So what we need to do is we need to reset the counter. By resetting the counter, we will put the counter back to 0, and we will start to count to 10 again. So if we're trying to keep, tabs on something, or the number of boxes, maybe we're trying to, put 10 boxes on one pallet, perhaps, if we're in a packaging situation, we would count to 10, and then we would want to reset the counter and count to another set of 10, reset, count to 10 again. Maybe the pallet can only handle 10 boxes. If we didn't reset the counter, then, like I said, the counter will just continue to count upwards. The other version of this is a countdown. So the countdown works in the opposite manner. We're going to start with a value such as 10, and we're going to count down from 10 to 0. And when the counter reaches 0, that's when the Q, or the output, will turn on. So it works the same way. We're going to trigger it with a discrete input, which typically goes into the CD. CD standing for counts down. That's where we put in our trigger point, our discrete signal. Every time we trigger it, it'll count down by 1. We will start from 10. We will go down to 0, and then we will reset it and do it again. The difference between the count up is that we don't use the term reset here. We're going to use the term load. And load essentially means that we're copying whatever is in the PV and putting it into the CV. So in the count up version, the counter starts with 0 in the CV, and we start counting up from 0 to the until we reach the PV, defined PV value, which in our case is 10. In this case, PV will be, what do we want the counter to start at? And instead of a reset where we're bringing the counter back to 0, we're going to do a load, which will basically put that starting value into the CV as our point, where our starting point for the counter to count down from. So it's important that we load the counter, and we'll need to load the counter first time we actually use it. So we'll have to use the load feature. And just like the reset, the load is a discrete trigger as well. So it could be, we could use a push button to initiate the load, and we can use a push button to initiate the reset in the count up. The third type of counter that we're going to play with in this lab is a count up down. So this one basically takes the features of both the count up and count down and put them into one. So we'll be able to use one counter to count up and count down at the same time. So we'll have two inputs into this counter. We'll have a CU and a CD. The CU will be when we trigger the CU, we will count up by one. When we trigger the CD, we will count down by one. And now we have a reset and a load here. So if we wanted to clear the counter and bring it back to 0, we could trigger the reset. Or if we wanted to bring the counter up to a preset value and then count down from that, we could do that by pressing the load. And then we have the PV, which will be our program maximum value, which again will be 10 as in all cases. And then we have a couple of different outputs. Those are on the left-hand side, or I'm sorry, the right-hand side here. We got QU, QD, and the CV, of course, will be our count value. So the QU would be when we've reached our upper limit. If we reach 10, then the QU will turn on. And QD will be if we reached our lower limit, which would be 0, the QD would turn on. So we can use those two outputs and use those in our lab. Probably more specifically the QU. So as far as the lab goes, we have 3 exercises, each one using those counter blocks. So we call them skills. So skill 1 will be count up, and basically we're going to use the premise I described a little bit earlier. We have a photo eye, a photoelectric sensor, nothing more than a light beam sensor that gets triggered every time a box passes in front of it. When the box passes in front of the sensor, again, the light beam gets broken. The sensor sees that as a transition to a high. Basically, the sensor turns on. Basically, a discrete contact closure happens, and we will send the signal to the PLC. The PLC will see that as a on. When that happens, we will feed that into the counter. So we will trigger basically we'll simulate this by triggering the input for the photo eye. When it goes to high, the counter will get that high signal and it will count the counter up by 1. Then we have to clear that signal back out again to 0, and then we can do it again and again and again, and we can count up and up and up. When we reach 10, we will turn on an output that basically says that the conveyor has been, that we've reached our count, and that we've counted 10 boxes. So we'll turn on an output basically, or belt exceeded is the terminology I'd use. But basically, we reach 10, we're going to turn on an indicator and let somebody know that we reached 10. The second skill will be the exact opposite. We're going to use the CTD, or the countdown. So now we're going to start the counter at 10, and we're going to count down from 10 to 0. And we're going to use a different photo eye this time. We're going to use what we'll call the exit photo eye. So the countdown, or the count up, we would have the what we call the entrance photo eye. So we're looking at boxes that enter the conveyor. And now that we're going to do a countdown, well, we could probably look at the exit sensor, or the exit photo eye. So we're looking at the boxes that are leaving the conveyor belt. Therefore, we can count down from how many have left the belt. So same will apply. Every time the exit photo eye gets triggered by you turning it on and off, simulating it by turning it on and off, the countdown counter will count down by 1. But again, we must press the load button initially to load the counter to 10, and therefore count down from 10. And then when we get to 0, we can press load and reset the counter back to 10. The third skill will be the condition where we're going to use the count up and count down timer, the CTUD. And the premise of this one is that we'll have like a buffer on the conveyor belt. And our buffer is we want to make sure that we stay under 10 boxes in that buffer. So we're going to count the number of boxes that are entering and count the number of boxes that are leaving, and we'll have a overall count of what is on the conveyor. That way, right? We know what's coming in, we know what's going out, and we can keep a track of how many boxes are in that buffer. If that number of boxes exceeds 10, or if it gets to be 10 or more, then we're going to shut down the belt. So part of the project too here in skill 3, or part of the program, is we're going to write a little bit of code to start and stop the motor for the conveyor belt. Because the conveyor belt is nothing more than a motor that gets turned on to make the conveyor belt move. So just like we did in some previous labs, we're going to use that same kind of latch circuit with a start and stop push button, so that when I press the start button, the conveyor starts running. When I press the stop button, the conveyor stops running. And if the number of boxes are 10 or more, that'll also be a condition that'll make the conveyor motor turn off as well. So those are our 3 labs. Now let's go look at CCW, or Kinetic Components Workbench. So one more thing actually before we leave the document. I did give the ladder of how these look, so you can use that as a reference. I also gave you the tags and the I/O points that we'll have. So for all the labs, we will have these tags in the controller. So for inputs, we will have the photo I in, the photo I out. We'll have a reset button, load button. We'll have the conveyor start and the conveyor stop. So those will be our inputs. And then for our outputs, we'll have the belt exceeded. We'll have the belt empty, which is what we're using in the countdown lab. We'll have the buffer exceeded, which we'll be using in the skill 3, and the conveyor motor, which is also used in skill 3. All right, so now let's go to CCW. I went ahead and made an example program, and I went ahead and defined the aliases just like I did in that chart. So here, but remember in CCW that the DOs, or the discrete outputs, come first. So DO 0, 0, 1, 2, and 3 are defined just like I showed in the chart a minute ago. And then our discrete inputs, which are the DIs, DI 0, 1, 2, 3, 4, and 5, and they are aliased just like we talked about a moment ago. I also went ahead and created 3 programs. I created one for skill 1, skill 2, and skill 3. This is not necessary to do. You could just create one program and just keep changing the logic for each time and testing it. But I did this just to make it easier to show on the video. So if I open up skill 1, this is essentially all we have to do for skill 1. We're going to have an input. Right. First, we have our counter. Of course, our CTU is our counter, is our count up counter, and we have to trigger the counter. We have to give it an input in order for it to trigger. There's no input to the counter; it'll never count anything. So, like we said, our input to this counter is going to be our photo I in. So the entrance photo I. So we're looking at at the beginning of the conveyor belt, there'll be a photo I, and it'll look at whenever a box enters the conveyor. So we'll use photo I in, and that'll be tied to discrete input 0, 0. So that just gets wired right to the CU of the counter. And then we have an output of the counter. So once again, when the counter does reach its maximum value, which is set here in the PV box of 10, we just put the number of 10 there as our constant. When we reach 10, this output will turn on. And when that output turns on, we can use that to drive the output for the belt exceeded indicator, which will be a discrete output DO 0, 0. And the only other thing we have to do to a counter at this point is we have to tie a reset to it. because if we don't put a reset to it, then the counter will keep counting up and up and up and up. So we have to be able to reset the counter so we can clear it and bring it back to 0. And I went ahead and indicated in the assignment that we're going to use discrete input 02. We'll make that our reset. So we just actually put the instead of putting the contact into the reset, we're just going to put that trigger, that address of the trigger right here in the reset box. So the IOEMDI02, which is tied, again, aliased as reset. So let's watch this guy in work. So what we're going to do, I'm going to use the simulator because that's going to be what I have available for me. So we're going to go to Tools. I'm going to open up the Micro800 simulator, and I have it right here. Now the simulator is not running, and I know that because the power light is not on, neither is any other indicators. So I'm going to go ahead and start the simulator. So now the simulator is running. That is green, as well as I have a green power light. And I'm going to go ahead and download this project to the simulator and make sure that we actually have it, put in and working. It's going to ask, do you want to download to the controller? We're going to say yes. It will prompt another time here in a moment. Do you want to download? And we're going to say download. And we'll get one more prompt, and that will be, do you want to put the controller back into the run mode once the project has actually finished its download? Right, download's complete. Do you want to change the controller to remote run and execute the controller project? And we're going to say yes. One more warning comes up, just says that the simulator can only operate in the run mode for 10 minutes, and that's just a limitation. And we will say okay. So you got 10 minutes to test. All right, so now we are actually online and connected to the simulator. We know that because the background has changed yellow, and we actually can see the red. We can start to see, some of the animation here of the line. Now, I'm going to bring the simulator back up so I can actually show these two things simultaneously. So right now, our CV is set to 0 on the counter, and our preset value is set to 10. So 10 again is going to be where the counter will trigger. When the counter will be when it reaches 10. When the CV reaches 10, that's when this cue will turn on and turn on the belt exceeded output. So to make that happen, we have to trigger the input. So photo I input 00. So if I cycle it, there's our count to 1. I'll cycle it again. There's our count to 2. Cycle it again. Now we're to 3. All right, and keep doing that 10 times. Now what I want to show you at this point is if I do trigger the reset, which is the DI02, if I trigger the reset, that will clear the counter back to 0. And it's going to start all over again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and the last one is 10. Now when I reach 10, this turned red and my output turned on. So so my output is tied to the I think the DO00. Now if I trigger this one more time, I will continue to count. Well, I guess not in the Micro800, so looks like it will not allow you to go past 10. Some controllers will continue to count up regardless. Micro 800 just actually does clamp it. Now I'm going to go ahead and hit the reset button. And now when I hit the reset button, that brought the CV back to 0. And it also turned off 0, 0, which is this output right here. So the output turned off and this cleared back to 0. So now I can count up again, start all over again. If I hit reset, brings it back to 0. Okay. Now let's go look at skill 2. Skill 2 is basically the exact same ladder diagram, with the exception of we put in looks like I made a mistake here. Nope, I did not have skill 2 open, so I opened up skill 2 here, and skill 2 is CTD. So I have multiple programs. I didn't realize that I was still in skill 1. Now I'm in skill 2. I'm going to reconnect to the Micro 800 simulator. It should not prompt me to download anything since I have since I didn't change any logic. So I just got connected, and so what's happening is right now the photo eye out, of course, is not being triggered. I'll bring up my simulator again to show you, right? So the DI01 is going to be my photo eye out, but my output is actually on, saying the belt is empty, and that is true because there is nothing currently on the counter. So like I had mentioned when I was introducing, on the countdown we have to load the counter prior to starting to count. On the count up, we don't do that. We start with 0, we count up, and then we reset it to bring it back to 0. On the countdown, we have to load the counter first to put the value into the CV, and then we count down from there. So I need to trigger the load button, and the load button is tied to the discrete input 03. So I'm going to trigger the load button. When I do that, it actually put a 10 in CV. So what load does is when I press the load button, it'll copy whatever is here in the PV and move it into the CV. So now we're starting to count from 10. When I did that, this also turned off because this is no longer 0. So this works the exact same way now. So I'm just going to trigger the photo eye out 10 times. When I get to 0, this will turn on. So again, it's the DI01. So down to 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Once we get to 0, the output turned on. So we got our output turned on. And once I press the load button, we now reset that and it's good to go. And the last one is using the count up down. Now, I'm going to clear these out because I was using the same reset and load here that we used in the previous labs. So I'm going to go ahead and press the reset button and clear everything out. Now, there were 2 pieces to this last skill. One, we wanted to have a simple motor start kind of logic so that when we press the start button, we would start the conveyor motor, and the conveyor would stop if I either pressed the stop button or if we exceeded our buffer. If we had more than 10 boxes or 10 boxes or more on the belt at one time, we were going to shut down the motor. Then we had in rung 2 our CTUD, which is our count up down. So we have a CU input for counting up input. We have a CD input for counting down. So when CU gets triggered, we count up by 1. When CD gets triggered, we count down by 1. Then I have a reset and a load. And I have my PV, which is my program maximum value. So that's 10 is our number, just like before. And then we have 2 outputs. We have a QU, which gets tied right to a coil. We have the QD, which is if you're at basically 0, the QD gets turned on. So it is showing true right now because our CV is set to 0. So we're at the lower end of our count. So we can use that output if we needed to let us know that we have an empty belt right now. And CV, of course, is our count value. So we're going to use the same 2 photo eyes that we're using before, the zeros, DI00 for the photo IN and the DI01 for the photo I out. And I hit the reset button already, so we're all good to go. So we're going to start the motor by pressing the start button, which is DI04. So I built the latch circuit, so I was able to just pulse the start button, and I have my latch around with the conveyor motor contact itself. So I got the conveyor stop, and the buffer exceeded is normally closed. If any one of these 2 opens, then our conveyor motor will turn off. And there's our conveyor motor output right there, so we can monitor it in the simulator. And here we're going to count up. So buffer, so we have 1 box comes on the belt, and there now we're at 1 box, another box comes on the belt, 3rd box comes on the belt. Oops, didn't get that one. Looks like I reached my 10-minute time, so I'm just gonna go ahead and just I'm gonna disconnect from the simulator. I'm just gonna shut it down. I'm going to reopen it. Start it. And I'm going to, oops, press the wrong button. I'm going to connect to it. All right, I have reconnected, and I am back online with the controller. We can see that our count values remain 2, even though I shut the controller, the simulator down and brought it back up. And now I'm going to continue to trigger my input. So this is actually a good piece of troubleshooting because I was sitting here trying to operate the thing, and it's not going, and mainly because we do not have the run. It is not running right now. So I can change its run status by coming up here in CCW and saying run mode. And I probably did not catch that earlier. So after the 10 minutes timed out, it changes. It dropped off a run mode. Would have had to just put it back into run mode to get it running again. So very important piece of troubleshooting with any kind of hardware or any type of PLC, regardless if it's simulator or the real physical hardware. If that run light is not on, it is not running. If it's not running, then it's not actually executing the program. So always keep that in mind. So we are sitting at 2 still, and I'm going to go ahead and keep triggering my photo eye. So now we're 3, so we're back running again. If I were to trigger the out, you'll see that my count does actually go down. So now I'm back to 2. I'm going to keep counting up. So basically we have tested that I can, add to the buffer or subtract from the buffer by using the 2 photo eyes. I'm up to 6. What I want to get to 10 so that we can see what happens. One more. And there we go. So we reached 10. When 10 occurred, we got our buffer exceeded output turned on. And when the buffer exceeded turned on, that opened this contact, and therefore we dropped out our conveyor motor. Now, what's important here is that if I were to reset this counter, this brings it back to 0. And it also brought the buffer exceeded back, right? Turned it off. But we did not start the motor back again, right? Because we did this latch. So we have to press the start button on the motor to restart the conveyor. That'll take a human operator to go and do that, which is usually good by design. Have some safety there. So we're going to start the motor back up again. So now we're running again, and we can start our buffer counter once more. So for the lab, I want you to just basically do this and just play around with the counter. Use the ability to to trigger it on and off, and see how the counter behaves. Reset it, and just kind of get comfortable with understanding the operation of the count up, count down, and the count up down blocks.